Hey guys, I'm back with another one. So, this will be episode 4 of Learn With Me Python. And before we jump into it, I want to get into something it's kind of important to me. I want to talk about what it takes to get good at this programming stuff. So, I've been programming for about 5 years now, and I still feel kind of new to it. I've learned a lot along the way, but most importantly, I learned that reading books and watching videos is a great way to get familiar with something, but it's not actually a really good way to say that you learned or know something. That is to say that you can't watch my video and feel like you learned something. You actually have to do the things that you see me do in order to have programmed it into your own mind, right? So if you're watching this video, I challenge you to go ahead and also type along with me. Open up another window and pause for a moment and type whatever was the last thing I just did. And ask yourself questions about, hey, why did these guys do that? Really check it out. Don't just watch the video and eat popcorn, because that's not really gonna help you. It would be honestly a waste of your time. So that's really all I wanted to say before we get going. All right, so I'm up 4:44 in the morning, and today is a good one. We're going to be going over inheritance rules in Python. We're going to go over how Python handles class inheritance. This one will be extremely interesting and supremely useful, seriously. Also, I just want to let you guys know that I'm figuring this stuff out as I go along. So right now, I'm shooting at 4K. I'm actually pretty happy, and I bought myself a little light stand on that, so it's looking a little bit different. I'm off to the side, but we're gonna continue, I guess, by viewing the screen. So don't mind me if I look a little bit distracted when you see my non-haircut situation. I'm a dad, guys. I'm a dad. All right. So how does Python handle inheritance? So Python is a bit interesting when it comes to inheritance, because it has different rules from other languages that I've used in the past, primarily Ruby. But to be honest, object inheritance is quite straightforward, right? It's very straightforward. So I'll go over Python's way of going through this. All right, very first thing you need to know. I'm gonna create a class. What should we call this class? We're going to call this class base. So this would be our base class. We're gonna put a method on this. I'm gonna call it F. And then we're going to give F. So this way you'll know what's being called, right? Just gonna call it F. And then we're gonna create a subclass. Class sub sub is gonna inherit from base, and then we're gonna give it a, we'll skip the initializer right now, but what we'll do is give it F. We'll get into the very first thing to know about sub dot F. All right, cool. Let's move this over a little bit so we can actually see all the stuff that we got going on here. Can't really even see it. Hold up. Darn it. What's going on? Why is it not looking so hot? Let's see. Ah, here we go. All right, cool. Now you can see it a little bit better. All right, so we have a base class and we have a subclass. Now, traditionally in Python, what will happen when we call sub? When we call sub, if we do not have an initializer, then the initializer for the base class will be called. And we can see that here with this example. So we're gonna call it sub, instantiate the sub object, and then we're gonna print sub. As you can see, the base initializer was called. Now, that is the first thing to know. If a class is defined without an initializer, then the base class initializer is called. Okay, so if you want your initializer to be called, then you actually have to make one for the subclass. So you can override the initializer for the that is being inherited from the base class. Let's see how that works out. Define init, call it self. I love these little theoretical ones. I'm gonna call this sub initializer. Cool. So now when we call sub, we should see sub initializer. Great. Now, in Python, if you want to call the initializer of the base class, it won't happen automatically unless you didn't create an initializer in your subclass. So what you need to do to run the base class's initializer is to call super. So you do this, super and now the base class's initializer is ran, and then also the subclass initializer is ran. Okay. What does inheritance mean? Inheritance means that you basically get methods from the base class and other base classes for free. This is how our entire libraries are built. This is the biggest thing that you're gonna get from any of this stuff that I'm talking about here is you're going to get the wherewithal to create a library for yourself. That's what we're headed to for right now. We want to be able to read libraries. We also want to be able to create libraries if need be. All right, cool. So we have that, and all of that is good. Let's get on to this next part. How to tell if an object is an instance of another class. Okay, so this one is pretty straightforward. So in Python, there are two methods: is instance, and it takes an object. So in our case, we'll give it sub, and then we want to see if it's an instance of base. So we'll give it the base class. Call it, and it should return. What do you think? I think it should return true. All right. Print. Always gotta be mindful of that. I'm in REPL and this happens a lot. So yes, it returns true. But with this instance, you can give it multiple objects to check if the instance is of any of the types that you give it. So I'll kind of defer to this right here, is instance, and we'll call this base. We're gonna pass a tuple to is instance, and then we're gonna give it object. I think this is also true. Object is modified. Object. Okay, so that works, and it's true. But it's not clear. So we normally use in Python, or an alternative thing that you can use in Python is called is subclass. All right, so how do you use is subclass? The way you use is subclass is you give two classes, not an object, not an instance, but two classes. So it is subclass, and it'll check if the class that you give it is a subclass of the class that you're checking for. So in this case, we'll say is subclass of base, and I would assume that the answer should be true. Yeah, that's true. To get away from a little bit of distraction going on in here, what I'll do here is I'll just remove the super, and I'll run, and cool. So yes, the sub class is also a subclass of base. Cool. Now let's get into multiple inheritance. So what exactly is multiple inheritance? Multiple inheritance is basically defining classes with more than one base class. That's pretty much all it is. So we're going to use base and sub. Well, I'm going to create another class, and I'm going to call it base 2. So I'm going to go back to this top level base 2. So define init. And this, I'm gonna call it base 2 initializer. All right, cool. So this is a base 2 initializer, and then we're going to do define so just to keep the API, intact. This is gonna call print and then we'll do base 2 dot f. All right, cool. So all of the classes have f as a function, and they all have initializers. So now I'll just go back over here, and we'll begin talking about sub or multiple inheritance. All right, so what does Python do when the same name method is defined in multiple places? So we have f in all of the classes, right? And let's say we instantiate sub. Instantiate sub. Well, actually, we've already instantiated sub. We're gonna call f on sub. What Python will do is it will run f that is defined on the instance class that you're directly on. If it's available there, it will just run it. So we should get, as we would expect, f running here. And you see this? It says sub f. But let's say, for instance, f is not available in the base class, right? Well, f is not available in the subclass. And we have multiple inheritance, and we do this. We say base 2. So we have this base 2 class right here. we run F, and then you would expect F to not run because it's not available on the subclass. However, it will run, but it will run F as a version from base. So you should see that hit. Now, if F is no longer available on the base class, then what will we expect? Base 2's F will be run. So this is basically how inheritance works. You drop a class into your project, right? You make whatever like local classes that you have available, well, inheriting from these like third-party libraries, right? And then magically through method resolution order, which Python does to give you this property, you'll be able to have access to methods that you didn't write or that are defined in another class that gives your object that you have currently some, extended ability, right? Now, what if, let's say for instance, that you needed to have F, but you also wanted to put some extra logic on top of the F that you have in the class that you're writing. So the way that you would work that in Python is to do this. You would define F. Well, hold on, let me put that back. You would define F. And then when you define F on your direct class, you would just say super, right? Super F. And then the direct base class, the first base class, right? F will be run along with your extra logic here in the order that you put super. So what that means to say is that when you run this, you should see base F, and then, hold on, let me put this back. This will be sub F. You see that? You see base F, and you should also see sub F. And it will run in the order that you send it. So if you do that, then it should change order. Sub F will go before base F. Now, that's pretty much it for that. Like, when it comes to multiple inheritance, the MRO of a class determines the order in which the inheritance graph is searched to find the correct implementation of the method. All that means is that the inheritance and graph of sub, the MRO, will just search up the chain. It will search right on down it, and then just get the very first named method that matches the name that you're calling on the object. That is it. It's not rocket science, guys. It's that is all that's being done there. All right, so now let's see. Now, this is something that I found really interesting about the MRO. I've done a lot of work with Django, and in Django, there are times where you can define a class and Python just simply blow up. It would just straight up blow up. So I'm gonna give you an example of Python doing this blowing up situation. So the very first thing we're gonna do here is we're gonna call sub.mro, right? We're gonna see what the MRO is for sub. Because I don't have an instance, I have an actual class that I'm accessing there. Print sub. So as you can see, the very first class is sub. the second class is base, and then the last class is base 2, and everybody is inheriting from object. Every class in Python inherits from object. That's just a fact of developing in Python. Python's object class is a special class and it enables a lot of different, I guess, what do you call it, dunder methods that you can override to give like superpowers to the classes that you're defining. And yeah. So we see the MRO there. And what else? What do we need to see here? Now, let's go over this interesting thing that I saw. All right. Here is an excerpt from the book that I'm reading. Before we move on to looking at super in detail, you might be curious about how Python actually calculates the MRO for a class. The short answer is that Python uses an algorithm known as C3 linearization for determining MRO. What that means is, 1, a C3 MRO ensures that subclasses come before their base classes. 2, C3 ensures that the base class order as defined in the class definition is also preserved. 3, C3 preserves the first 2 qualities independent of where in an inheritance graph you calculate the MRO. In other words, the MROs for all classes in a graph agree with respect to relative class order. So something like this can't happen. I'm just gonna block all that out because this is the very last topic I'm gonna go over. C3 linearization and why you can't write this. So we have a class A, we define class A. Then we define a class B. And then we give it access to A. And then we also pass on that. And then we have a class C. We give it access to A. Can't see it. All right, so this can't happen. So we have class A, we have class B, and we have class C, A, class D cannot have B, A, C. Cannot create a consistent method resolution order MRO for bases A and C. So all this means is that because everybody is inheriting from A, that A cannot come before any of the subclasses. The base class cannot come before the subclass. All subclasses must come before base classes. So this is how you resolve any of those errors that you will eventually see in a while. There you go. That's it. That's really all it. In multiple inheritance, the order in which you inherit actually matters because the MRO is generated from the order in which you're inheriting, and then you have to know that subclasses always have to come before base classes. That's it. That is it. That's really all there is to that. There's a heck of a lot more, but I wanted to be succinct about all of this, and I genuinely enjoyed talking about this. I got into the groove. It is now 5:07 a.m. I gotta go, guys. I just gotta go. But let's stay tuned for episode 5 because that's gonna be fun. That is gonna be fun. Peace.